Okay, so what you should have done is focus on part 1. Identify that you've got P and Q as your output values. Ding, ding. And you've got A, B, C as your inputs. Now identify the gates. So you've got an and a NOR. So we started off with the zeros on our truth table. Everything's a 0. A, B, C. If we did A and B as a 0, P will be 0. Q will be, if we did B and C being 0, 1. Because remember, 0 or 0 should be 0 on an OR gate, but we're using NOR, so 0 will turn into a 1. So let's have a look. Ta-da! Now, let's have a look at the next one. If we had A0, B0, that still should be a 0. C being a 1. So B is a 0, C is a 1. That should be a 1 if it was just an OR gate as a result, but we've got to turn 1 into 0, which is 0. Same again. If B is a 1 this time and C is a 0, it's going to be 0 and 0. Now what happens if we've got A being 0, B being 1? That should be 0. We've got B being 1 and C being 1. So 1 and 1 should be 1, but we're using a NOR, so it'll turn it to a 0. Which is correct. 0 and 0. Okay. If A is 1, B is 0. 1 and 0 is 0. So we have C being 0. 0 and 0 equals 0, which is fine. Or 0 equals 0. However, because we've got the NOT turns it into a 1. Let's have a look at the next one. If A is 1, B is 0, C is 1. 1 and 0 is 0. 1 or 0 is 1, but turn it into a 0, so it should be 0. A and B, let's just clear the pen. A and B are 1, which means 1, yay. C is 0, 1 and 0 is 1, so 1 or 0 is 1, but because we've got this bad boy here, it turns into a 0, so it should be P is 1, Q is 0. And finally, 1, 1, 1. A and B is 1. C, on the other hand, is also 1. So we've got 1 and 1, or 1 or 1, between B and C, which should be 1. However, we've got the NOT. What does the NOT turn it into? A 0. And there you go. Here is our truth table for the circuit. All done. Every combination. Every possible combination. For part 1. Now we're going to do part 2. So part 2 has 2 new inputs. That's P and Q. And it has only 1 output, which is R. We know that this gate is an OR gate, so this should be relatively simple. 0, 1 is 1, 0, 0 or 0 is 0, 0 or 0 is 0, 0 1 is 1, 0 and 0 is 0, 1 or 0 is 1, 1 or 0 is 1. So that is really, really simple for part 2. So we've got our whole truth table putting together. Part 3, where we're focusing on C as an input and R as an input. This is where it could get quite confusing, so do pay attention. So all we're focusing on is C. So let's just put a little shape around that. And let's make it there we go. C and R. Let's focus on those. Now if you remember, this gate here is going to be an XOR. Okay? Now an XOR is basically, if a number is an odd number, it'll turn it into a 1. So if C is 0 and R is 1, X will be 1 because it's an odd number. 0 and 1 is an odd number. Pretty simple so far. Let's have a look at the next one. If C is 1 and R is 0, it will still be 1 because it's an odd number. If C is 0 and R is 0, it'll be 0. If C is 1 and R is 0 again, it'll be 1. The reason why it's repeated is because it's repeated for the other ones. We put all the tables together, so you might have some repeated data. If C is 0 and R is 1, it'll be 1. If C is 1 and R is 0, it'll be 1. If C is 0 and R is 1, it'll be 1. And if C is 1 and R is 1, it'll be 0. Now this is a whole truth table put together. So when you're doing the truth table, you will lay it out like this, all in one go. That is why we've got some multiple zeros and ones here. Because these zeros and ones come from the beginning, part 1. So R needs to answer those. Therefore X does as well. Now these are called intermediate values, P, Q and R. So P, Q and R. That's because really a truth table should be A, B, C and the output X. But you need to work out the intermediate values by laying out like this so that you can work out X in the first place. So imagine if your truth table looked a little bit like this. This is actually a proper truth table where you've got your input values A, B, C and your output value X. And basically you get to X by working out P, Q and R. However, working it out this way can get quite confusing, which is why it's very useful to have the intermediate values on there as well.